All right, I'm going to be going over your review now. Number one, an artist is making a scale model of a statue. On the model, 2 inches represents 1 foot on the actual statue. Which graph best represents this relationship? So here I need you to look at your units on the graph here. So it's labeled inches on our x-axis and feet on our y. So right here I have 2 inches in 2 feet. Here, this crosses way down. This is like, I don't know, maybe a 16th of an inch or feet, a foot. So we've got 2 inches at a very small amount of feet. We're looking for 1 foot. Right here, I have 2 inches, and then it's approximately 1 foot. So that works. And on this last one, it is 2 inches to 12 feet. So your answer choice that you wanted to have was choice C. We have 2 inches and 1 foot. All right, number two. Which of these does not represent the distance a car travels when going 55 miles per hour? D equals 55 times T, where D represents the distance in miles, that represents time in hours. So that's correct, right? 55 times time, right? Here on my table, I've got 1 hour is 55, 1.5 is 82.5, 2 is 110, 2.5 is 137.5. So that works. I'm going to skip the correct answer. So here I have 1 hour is somewhere over 55, right? And that, okay. 2 hours is between 100 and 125, so that works. We're looking for 110. 3 hours. 4 hours. So if you calculate this out, these all work. Here, on the other hand, though, this is the one I worked out. 3 hours. So in 3 hours, if we're going 55 miles per hour, and that's what I did over here, 3 times 55, and I got 165. So the car, if it was traveling 55 miles per hour, it would have went 165 miles, not 160. So that's why that one does not represent that distance. Number three, during migration, a butterfly can travel 30 miles in 1 hour. Which graph best represents y, the number of miles a butterfly can travel in x hours? All right, so on A, we have 5 hours to go 30 miles. Well, this butterfly can go 30 miles in 1 hour, so that's not right. All right, this one I have an hour, 30 miles in 1 hour. That one works. Let's make sure the other ones don't. Here, I'm going to go 5 miles in 30 hours. So that does not work. And then here I have 1 mile in 30 hours. Again, we're looking for 30 miles in 1 hour. So B is the correct answer choice. Number four, Caroline's cell phone plan costs $32 per month. Which table shows the sum of the amounts that Caroline will pay for her cell phone plan over the next 4 months? So on all of these, we're looking for, first we've got to start out 1 month at 32. So that F and G could not work for sure. Here, this one is only going up by fours, and we need to go up by 34. So $32, 64, 96, and 128. And that's what I worked out over here. This is 1 month, 2 months, 3, and 4. We're just adding 32 to each of them. So J was the correct answer on that one. Number five, a dolphin travels through water at a speed of 25 kilometers per hour. Which representation shows the distance a dolphin can travel at this rate? So I'm looking at these changes. So my changes in Y over my changes in X. And the dolphin is going 50 kilometers for every 2 hours. So that one works because it's going 25 in 1 hour. So 50 every 2 hours would make sense. We're doubling both of those. B says y equals x plus 25. That's at one point they're just going up 25. It doesn't tell me every single hour we're going. So that would be that would have to be right here, which is what I showed here. C, this graph is showing 1 kilometer in 25 hours. So they've got the units backwards, so that would not work. And then D, in 5 hours, a dolphin can travel a distance of 135 kilometers. And right here, I've worked out a dolphin can travel 125 kilometers in 5 hours at that rate. Number 6, Gail worked out at a gym for 2 hours. Her workout consisted of stretching for 21 minutes, jogging for 45 minutes, and lifting weights for the remaining amount of time. What percentage of Yael's workout was spent lifting weights? So first I wanted to figure out how much that was. So I knew that 2 hours is 120 minutes. And I needed to find out stretching and jogging, so I added those up, and that was 66 minutes. So to find out how much time she spent lifting weights, I subtracted 66 from 120, and she spent 54 minutes lifting weights. So then to find out that percentage, right? So what percentage? I had to divide. So 54 divided by 120, and I got 0.45. And then to convert from a decimal to a percent, you just move right 2 places, that decimal point, and we have 45%. So 45% of her workout was spent lifting weights. Number 7, every 2 days, a scientist spends 1.25 hours observing dolphins and 3.5 hours observing sea lions. At this rate, how many total hours will the scientist spend observing dolphins and sea lions in 6 days? So I had to look for 2 days first. So in 2 days, I had to add up the sea lions and the dolphins, right? Sea lions and dolphins. That was 4.75 hours in 2 days. And then 6 days is 3 times that. So I just multiplied by 3. And I had a decimal point, 2 place values here. So when I had my product here, I needed to move that decimal point 2 places to the left. 14.25 hours. Number 8, Amanda increased the amount of protein she eats every day from 48 grams to 54 grams. By what percentage did Amanda increase the amount of protein she eats? So first you need to find out the amount of change. So I just subtracted and I found out that the change, she's eating 6 additional grams. Then I need to find the percent of increase. So all I'm dividing here is 6, her increase, that amount of change, she increased 6, over the original amount, which was 48. When I divided that, I divided it over here. I got 0.125. And again, to convert from a decimal to a percent, and I did it right here, you move 2 places to the right, 12.5%. Number 9, the price of a video game was reduced from $60 to $45. By what percentage was the price of the video game reduced? Again, we need to find our change. The change in value is $15. You take your amount of change, divide it by your original amount, and you're going to get your decimal. You need to convert that to a percent, and that's 25%. Number 10, Zion plans to run 14 laps around a track. Each lap is 400 yards. So far, Zion has run 1,680 yards around the track. What percentage of the run has Zion completed? First, I needed to figure out how many yards 14 laps was, and that's what I did over here. And then I just needed to divide 1,680 divided by that total. And when I did that, so I've done my math over here, you all should be working these out on paper, so make sure you have paper and pencil with you. And when I divided that out, I got 0.3, and again, to convert from a decimal to a percent, you move that decimal point 2 places to the right, and we have 30%. Number 11, a boat traveled 27 miles in 2 hours. At this rate, how many miles will the boat travel in a half an hour? So I've done this one way, but I also told you could have divided by 4 if you can see that that's going to be a fourth of that, right? So to find out for 1 hour, I found my rate, which is 27 divided by 2. And that told me that the boat traveled 13.5 miles in 1 hour. To find a half of an hour now, from that 1 hour, I just need to divide by 2 or divide it in half. 13.5 divided by 2 is 6.75. Okay, so now I have 6.75, but we have all these fractions here. So we need to know that 3/4 is equivalent to 0.75. So that would be 6 3/4 miles. Number 12, Jose paid $47 for 4 movie tickets. Each ticket cost the same amount. What was the cost of each movie ticket in dollars and cents? All we need to do here is 47 divided by 4. And when I do that, I found out that's 11.75. And I would normally put a dollar sign here, but it would be a gridable, so you can't do that. It's $11.75. So $11.75. Number 13, Tarek pays $22.10 for 2.6 pounds of salami. What is the price per pound of salmon? Again, we're just finding our unit rate, so we need to divide 22.10 divided by 2.6. Remember, that needs to be a whole number, so we need to move that decimal point to one place to the right, which means I need to move this decimal point to the right. I've rewritten it. 221 divided by 26. And when I divide that out, I get 8.5, which is $8.50 per pound. Number 14, a package of 25 wristbands costs $5.25. At this rate, what is the cost of one wristband in dollars and cents? Again, we're just finding our unit rate, 5.25 divided by 25. And then we're going to end up with 21 cents per wristband. Number 15, a recipe says to use 3 cups of flour to make 48 cookies. What is the constant of proportionality that relates to the number of cookies made, y, to the number of cups of flour used, x? So we have our y over x, where k is equal to y over x. So I've done 48 divided by 3, and then I've divided it out here. 3 goes into 48 16 times, so we're going to have 16. Number 16, the cost of 3 pounds of grapes is $6.57. What is the constant of proportionality that relates to the cost in dollars y to the number of pounds of grapes, x? So again, we have y over x, 6.57 divided by 3, which I've done right here. So it is going to be $2.19. Number 17, at a school carnival, tickets can be purchased to participate in different activities. The table shows the total cost for different numbers of tickets. What is the constant of proportionality that relates y, the total cost in dollars, to x, the number of tickets purchased? All I've done is my y over x, and I have 2 divided by 8, which I've simplified to 1/4, and I know 1/4, because it's a benchmark fraction, is equivalent to 0.25. I have also taken this here, 12.5, or 1250 divided by 50, and shown that I got the same constant proportionality. So 0.25, and it doesn't matter which one you use, they're all going to be the same. Number 18, some doctors recommend that men drink 3 liters of water every day. There are approximately 29.6 milliliters in 1 fluid ounce. Which measurement is closest to the number of fluid ounces in 3 liters? So we have 1 ounce in 29.6 milliliters. And so we're converting to liters, right? So we've got to get milliliters to liters. So I know that 1,000 milliliters is equivalent to 1 liter. When I do that, I'm going to have 1,000 divided by 29.6. And when I divide that, I'm going to find out that it's 33.784 for 1 liter. So if that's for 1 liter, we need to find out how many are in 3 liters. So all I did was multiply by 3, and I got 101.352. So we're at approximately 101 fluid ounces for 3 liters. Chloe is 5.4 inches tall. There are 2.54 centimeters in 1 inch. What is Chloe's height in centimeters? So the first thing I did was converted her 5 feet 4 inches all to inches. And I know that 5 feet is equivalent to 60 inches. That's just multiplied by 12. And I added those additional 4 inches she has. So Chloe's height is 64 inches. Then I need to just use my conversion factor. So I multiplied 64 times my conversion factor. 64 times 2.54, and I've worked that out right here, is 162.56. So it's 162.56 centimeters for Chloe's height in centimeters. Option C. Number 20. Terry ran 8 kilometers. 1 mile is approximately equivalent to 1.6 kilometers. Which measurement is closest to the number of miles Terry ran? And I've used my 8 kilometers, my conversion factor, and then I had 8 divided by 1.6, which I've divided right here. Had to move my decimal point, one place value, which I've moved it here, and I had 5 miles. So 1.6 kilometers, and we've got 8 kilometers, so that was my conversion factor. I used that to convert 8 kilometers to miles, and I got 5 miles. Make sure you work out your problems on the test and do your very best and take your time.